Hello, is anyone home? I've come to ask if you've heard the good word of our Lord and Savior, Beyonce Knowles. Just kidding, I'm not here to indoctrinate you into the beehive. Okay, maybe I am a little bit. I'm actually here for our 7th class of Unit 2 to convert you to the cult of compound inequalities, this time, Part 2. Last time we were together, we got introduced to 2 types of mathematical compound sentences, namely those with which 2 words, 5, 4, 3, 2, 76. Well, I've got and or. We also saw how to write them, how to graph them, how to describe those graphs using our 2 notations, our set builder and our interval, and in class together we even started thinking about how to solve them. Today, we're going to pick up right where we left off. We want to continue to get at that big question from last time. With everything we know about these compound inequalities, how do we go about accomplishing our goal of solving them? So take this friend. -2 is less than 1/2 t minus 1, which is less than 3/2. If it's not your friend yet, it's going to be by the end of the problem. First of all, 5 seconds. Is this an and graph or an or graph? And how do you know? 5, 4, 3, 2, -3,000. Well, in this case, t is connected to some stuff, but it's sandwiched between -2 and 3/2. Anytime I'm sandwiched between 2 values, that immediately tells me that I got an and. So this is going to be the graph of an and I want to not only graph it, but solve it, so get t by itself, and write my 2 notations. But there's something a little different about the way that I go about isolating t in this case. What changes? What's a little bit different about solving this inequality compared to the other ones that we were working with before we were introduced to our compounds? Alrighty, maybe you don't remember in total, but you've hopefully got a little bit of an inkling from the work we did in class together last time. I want to get t by itself. Inverse order of operations hasn't led me astray so far. If it ain't broke, don't fix it. Easiest thing to get rid of first is probably the -1. Want to undo it by adding 1. However, the difference here, I need to make sure the imbalance stays the same. So before, I would think about adding, subtracting, multiplying, dividing to both sides. Here I need to make sure that if I do something to one part of the inequality, every part of the inequality gets the same operation. So if I'm adding 1 to the middle, I also need to add 1 on the right and on the left. All 3 parts of this inequality need to get +1. So taking it left to right, -2 plus 1 is -1, which is less than -1 and +1. These undo each other. I'm just left in the middle with 1/2 t. And then on the right, I'm less than 3/2 plus 1. I need a common denominator. Think of 1 as 2/2. 3/2 plus 2/2 is 5/2. And now I've just got to get rid of that times 1/2. Well, in this case, I need to divide by 1/2. But dividing by 1/2, think about it more easily. Keep, change, flip, Kentucky Chicken Fried. Let's instead think about it as multiplying by the reciprocal of 2. So I'm going to multiply all 3 parts here by 2. In this case, -1 times 2 is -2, which is less than 1/2 and times 2. These undo each other. I'm left with just my t by itself, which is, of course, what I want. And then 5/2 times 2 is same idea. Divide by 2 times 2. These go away. I'm just left with 5. So -2 is less than t, which is less than 5. There's my inequality solved. Let's graph it. On my number line, I'm going to give myself a number line first and foremost. That's real important. So think smarter, not harder. I could label the entire number line, but the only 2 numbers that are really important for me here are the -2 and the 5. I'm just going to give myself a -2 and a 5. Maybe I'll label my t, maybe I won't. It doesn't really matter. I like to get into the habit of it. -2 and 5. Looking at the symbols next to them, what's going to happen on the graph? What kind of circle do I need around the -2 and the 5? 5, 4, 3, 2, 7 billion. Well, I've got no or equal to. It's just a greater than or a less than, so both -2 and 5 should get some open circles. I'm not going to fill anything in. They're not included in the solution set. And then notice the values of t, they're stuck in between the -2 and the 5. So everything in between the -2 and 5 on the number line is what I'm going to shade in. Fantastic. Let's do our notations. Again, same idea as before. Nothing has fundamentally changed. Set builder notation is going to still be written exactly the same way. I need the set of values of t such that, well, what criteria have I established? The only thing I know here is that t needs to be between that -2 and that 5. And for interval notation, well, look at my number line. What did I shade in? Reading from left to right, I started on the left with the -2, and I ended on the right with the 5. So I'm going from -2 to 5. By the way, notice open circles here tell me in my interval notation, -2 and 5 both need what kind of thing next to it? Well, they're both going to get some parentheses. So -2 and 5, in this case, neither is included. Both have a parentheses next to them. So nothing's changed, right? Set builder and interval, we still write exactly the same way. Maybe the way that we shaded in the number line looks a little bit different, but the way that we write our notations is fundamentally the same. With what you've got, let's try one more. -3 is less than 13 minus 2x, which is less than or equal to 19. Let's solve for x, graph on the number line, and write our set builder and interval notations. Give yourself a 2-minute timer, see how far you get. Have fun. Whoa, that's too much fun. Let's finish this together. 13 minus 2x. I want to get rid of a 13. I want to get rid of a -2x. Easiest thing to get rid of first is probably that 13. Let's start by subtracting 13 from the middle. But if I subtract from one part, I've got to subtract from all 3 parts of my inequality. -3 minus 13 on the left is -16. Carry down my inequality symbol. 13 minus 13 is 0. This goes away. I'm just left with -2x. Is less than or equal to 19 minus 13, which is 6. And then I've got a -2x. I want to turn it into x. Let's get rid of that times -2 by dividing by -2. -2 divided by -2, these go away in the middle. On the left, -16 divided by -2 is +8, which is less than x here, which is less than or equal to 6 divided by -2, which is -3. And there you go, there's your inequality. What do you mean? Something's weird. What happened? Did I make a mistake? Is my life over? No, right? My life's not over. What did I forget? There's some choice that I made that I forgot to account for. Well, notice I divided by a negative number. And when I divide by a negative, what happens to my inequality? It does a backflip. So I need to take my inequality, put it down, flip it, and reverse it. But I need to flip the entire inequality. So my less than symbol, I'm going to swap out for a greater than symbol. My less than or equal to, I'm going to swap out for a greater than or equal to. There you go. So you can leave it like this. You're more than welcome to. I personally prefer to write things in ascending or increasing order. So I would personally flip this around. The -3 is smaller than the 8, so I'm going to put that first. And then I'll just flip my inequality totally. -3 is less than or equal to x, which is less than 8. Great. With that in mind, let's graph it. So here, on my number line, 2 most important things I need are a -3 and an 8. Let's put them there. -3 and 8. I'm going to label my number line with an x. Next to -3, it's less than or equal to, so that tells me here that I need a closed circle. And I've got just a less than or greater than symbol next to the 8. That tells me that this 8 is going to get a high 5. It's also going to get an open circle. And I know x is in between the -3 and the 8, so the part of the number line that I'm going to shade in is in between my 2 circles. There you go, there's your graph. Let's give ourselves our set builder and our interval notation, and then we'll do something a little different. Set builder notation. Well, I want the set of values of x. Specifically here, what do I know about x? It needs to be between that x and that 8, including the -3. And finally, for our interval notation, reading the part of the number line that I shaded in, well, I started on the left at -3. I ended on the right at 8. -3 has a closed circle, so it's going to get a square bracket, and 8 has an open circle. It's going to get a headache. It's also going to get a parentheses. Very nice. So you've got your notations, you've got your graph for your ands. Let's try some ors. And by ors, I of course don't mean that we're rowing a boat. I mean, you could be, who knows. 2p plus 1 is less than negative 4, or 3 minus 8p is less than or equal to negative 1. Remember from class, we'll do this first one together and then we'll do the next one. I'll set you free. What's the strategy for solving an or statement? I've got these two separate cases. How am I going to go about getting the value of p in each case? Well, hopefully, you might remember, if I've got two separate cases, the idea is to think about them separately. So I'm going to solve the inequality on the left, then I'll solve the inequality on the right, and once I've got both solved, then I'll worry about how I put them together. So, on the left, let's take this 2p plus 1 is less than negative 4. I want to get p by itself, reverse order of operations. Easiest thing to do first, let's minus 1 from both sides. On the left, plus 1 minus 1, these go away. I've got 2p is less than negative 4 minus 1 is negative 5. Divide both sides by 2 to get p by itself. On the left side, 2 and 2, these undo each other. I've got p is less than negative 5 halves. Or, in my other case, 3 minus 8p is less than or equal to negative 1. Let's start by subtracting 3 from both sides of this inequality. Minus 3 from 3, you get 0. Negative 8p is going to be less than or equal to negative 1 minus 3, which is negative 4. Last thing between me and freedom, got to divide both sides by negative 8. Alarm bells, alarm bells, alarm bells. I divided by a negative. What needs to happen? Because I divided by a negative, my inequality flips. So I'm going to take my less than or equal to, write it as a greater than or equal to, negative 8 divided by negative 8. These go away. I'm left with p is greater than or equal to negative 4 divided by negative 8. So there should be positive 4 over 8, which reduces to 1/2. So either p is less than negative 5 halves, or I'll use my funky symbol for it. What's the symbol for or again? 5, 4, 3, 2, 1. Well, it looks like U. It doesn't look like U. It looks like a U, the symbol U. So here, either p is less than negative 5 halves, or p is greater than or equal to 1/2. From here, let's graph it. So I've got two cases. Either I've got something to do with this negative 5 halves, or I've got something to do with this 1/2. If I'm less than negative 5 halves, around that negative 5 halves, no or equal to, I get an open circle. And then if I'm less than, I need to go off to the left. And then this 1/2, so I'm greater than or equal to gives me a closed circle around the 1/2. Then if I'm bigger, I need to go off to the right. So hopefully you remember here, the graph of an and statement always looks like a sandwich. I'm stuck in between the two values. For an or graph, it's a split. I'm on the outsides of those two values, and then I'll always have this empty space, usually in the middle. Cool. From here, let's do some notations. I've got my set builder, my Smash Bros, and my interval notations. Again, if it ain't broke, don't fix it. We're going to write it exactly the same way. The only difference here is that I've got an or statement to account for. So, set builder, I want the set of values of p such that, vertical line, I've got either p is less than negative 5 halves, or, use my symbol, p is greater than or equal to 1/2. It's got to be one of those two. And then finally, for our interval, look at the parts of the number line that I shaded in. Take the one on the left first. Well, this branch on the left, it starts all the way on the left. It keeps going, so right, it's beginning at negative infinity. And it ends on the right at negative 5 halves. Negative infinity in interval notation always gets a parentheses. Negative 5 halves, it's got an open circle. It also gets a parentheses. It's not included. Or I could be on the part of the number line to the right. So that tells me here, that part of the number line, it starts on the left at 1/2, and then it goes off on the right all the way to infinity. Infinity gets a parentheses. 1/2 has a closed circle. It gets a square bracket. There you go. There are your two notations. With this idea in mind, Let's solve the other one. 3b minus 5 is less than or equal to negative 8, or 2b minus 1 is greater than or equal to 5. Let's solve our two cases, graph them on the number line, and write our two notations. Again, nothing here is fundamentally changing, except now I've got an or to account for. Give yourself 2 minutes, see how far you get. Go ahead. Okie dokie, let's do it. 3b minus 5 is less than or equal to negative 8. I want to get b by itself. Easiest thing to do, let's start by adding 5 to both sides. So add 5 on the left, they cancel out. I've got 3b is less than or equal to negative 8 plus 5, which is negative 3. Divide both sides by 3 to get b by itself. On the left side, 3 over 3 is just 1b. And then I've got less than or equal to negative 3 divided by 3 is negative 1. Or, second case, 2b minus 1 is greater than or equal to 5. So, let's start by adding 1 to both sides. On the left side, they undo each other. I'm left with 2b, or not to be, is greater than or equal to 5 plus 1, which is 6. Divide both sides by 2 to isolate b. 2 divided by 2 is just 1, so I'm left with 1b is greater than or equal to 6 divided by 2, which is 3. So either b is less than or equal to negative 1, or b is greater than or equal to 3. On our number line, the most important things for me are the negative 1 and the 3. You're welcome to put more, but make your life easier, not harder. Talking about values of b, b is less than or equal to negative 1. So or equal to gives me a closed circle. Less than that negative 1, I've got to be off to the left. And then for 3, greater than or equal to gives me a closed circle. And then if I'm greater than 3, I need to be off to the right. So once again, I've got my split graph. Let's write our notations. For set builder notation, again, my criteria, I'm talking about all values of b, such that either b is less than or equal to negative 1, or b is greater than or equal to 3. And then for my interval notation, I could be in one of two parts on the number line. Either I'm on the second, or the part on the left, which started at negative infinity on the left and ended at negative 1 on the right. Negative infinity always gets a parentheses. Negative 1 here has a closed circle. It gets a bracket. Or I could be on the part of the number line that starts at 3 on the left, goes off to infinity on the right. Infinity, of course, always gets a parentheses. 3 has a closed circle. It gets a square bracket. Beautiful.